I'll give you one example. Now, you're gonna feel some pain when I tell you this, like that. But you should know this though, because otherwise you go buy expensive stuff out there. It doesn't work for you, like astaxanthin. Everybody know astaxanthin. Like that is good for you. Oh, like that. Astaxanthin has this side here, OH group here, another OH group here. So it's a double-headed thing. So that is a good antioxidant.
Uh-huh.
However, astaxanthin on the other end here has exactly the same thing here. So therefore, if you have a phospholipid, water soluble and lipid soluble, how are you going to expect? Think of this as a two-headed snake, a snake in the head and a snake in the tail. So if you have astaxanthin, this astaxanthin would work like this. It'll come out sticking out like that. This is as awkward as it's ever going to be because all the phospholipid are like this. How about for the moment you don't believe me? You go on a textbook and just Google and ask what a cell wall look like. Then you can see how is this monkey going to get into the phospholipid? It won't go in there. So therefore, do not take things that does not fit. It really doesn't fit. It has to be like this. So I usually tell people that an antioxidant that work, they look like a sperm or a tadpole, where the head is like this sticking out and this thing sticks in like that. Now, in the back of me, I'm going to go away now. In the back of me here, I want the audience to see this. Okay, that is a CoQ10 molecule. I'll take this away. See that?
Yep.
On the CoQ10 molecule, on the other end, that's the antioxidant. It sticks out, and this big, long tail sticks into the phospholipid. So when our body make CoQ10, it stay there. It is its permanent residence. It usually never moves from there.
Huh.
And also, if you take supplemental CoQ10, I'm tell you, everybody and their grandmother again, you will say the CoQ10 is 200 times more bioavailable, 300 times more bioavailable, making you to buy their product essentially. You know why they do that? They do that because they never tell you this. And probably they don't know. CoQ10 is such an albatross. It is very hard to absorb in the body. Just look at the darn thing. It's like an
Yeah, it's
albatross,
huge.
So and then when you go into the blood, that's only in the blood. This guy is supposed to be in the cell. So the best way to make CoQ10 is actually let the body make CoQ10. Probably evolutionary bend. Our body don't depend on external CoQ10 because it's very difficult for this very good molecule to be gotten from the outside.
Supplementation of astaxanthin is useless because of the shape, the chemical structure doesn't even make sense for it to even work. Is that what you're saying?
Yeah, for protecting the cell membrane. Astaxanthin
Got
may
it.
have other function in elsewhere. Just protecting the cell membrane, it doesn't work. Now, the leaf have to photosynthesize. It needs the opposite of what human being need. It needs carbon dioxide, and then it releases oxygen. That's how you remove carbon from the atmosphere. By the way, so if you don't do this, then all the carbon we produce, they're just circulating around. But they take the carbon CO2. You see, take carbon, and then they release the O2. You got the carbon in the plant. Very simple like that.
Yeah.
And then they make all kinds of chemical for you. That's a carbon sink. It's a beautiful carbon sink. Now, why in the fall it turn yellow and orange? It turning down its hormone. It's going to sleep now because it's going to go to hibernation. So then you see the beautiful yellow orangey color. What are they? They are keratin.
Yeah.
They are keratin like astaxanthin, like lycopene, like zeaxanthin, like that. Why are they there? They are there because the UV is radiating on the leaf. If we were to have our body like that, we would have tumor all over our body on the skin like that. But the leaf didn't. So the keratin is there to capture this oxygen-free radical, so the leaf does not get destroyed. Now that is where keratin works the best to protect oxidative damage. Notice that though. Let me finish that one. The leaf is not oily. So vitamin E in the leaf is no good. So if you want to protect the cytoplasm, vitamin E should not be there. It should be carotene. But if it is oil and fat, it should be vitamin E and not carotene. You got it? So
Yeah.
it depends on what kind of oxidation. But I think that for human being, when did you last see a human being that only have about 15% fat? It is rare. You will see a human being, we have the other end. We have 35, 40, 45%. We have that kind of a problem. If we have a 15% fat person, okay, they need other kind of antioxidant, vitamin C, other things that we can talk about more. But for most of us are not like that. During the ovulation cycle of women, there is a part called corpus luteum, and the highest concentration of lutein and zeaxanthin is in the corpus luteum. So this lutein and zeaxanthin is actually creation of life, like that. Most people don't know. We only know lutein and zeaxanthin to protect us from macular degeneration, filter out the blue light. Correct. But when it is inside the placenta growing, that's big time oxidation. And so the mother needs to be protected while she's feeding the baby. Carotenoids are important, but they do different things to protect oxidation. But if it comes to fat, then it is vitamin E. But other antioxidants have protective capability for other things in the body, but not necessarily the cell wall. The two major forms of vitamin E are tocopherols and tocotrienol. The tocopherols, you can read them in your cereal box. And then the tocotrienol, you just about not find them. If you go to a store to look for vitamin E, 95% of them will be tocopherol. Very few, about 5% tocotrienol. And in the tocotrienol, you're going to find three. The less common one is a rice tocotrienol from rice bran. And the second more common one is from palm oil, like that. And then this almost very little found is called annatto from this plant that I show you. Annatto plant, like that.
It's a
That
beautiful plant.
we use the annatto for coloring cheeses. Next time you see Dorito chips, cheese,
Interesting.
and then you can see this kind of a color. We remove the color, and then the vitamin E is in there. The vitamin E I discovered was about 25 years ago. I actually went to South America. This is a chance finding, and it's kind of spiritual to me. I went to South America after the discovery of lutein and zeaxanthin on the back of the retina, like that. Now everybody knows that it's for macular degeneration. Then people didn't know. I knew that if I look for a large a marigold plant, you can see a younger me in this book that I
Yeah.
under me, you can see that I'm looking for a marigold, but I did find the marigold plant. But about 30 feet away from me, I saw this annatto plant, and the color is again a carotene. Notice this. This is a very unusual fruit. It doesn't have a flesh. All fruit that we have a flesh, and then the color, that's a carotene. And carotene are super unstable. It's supposed to be bind to the cytoplasm or bound to protein, but this one stay in your hand. The British call this the lipstick plant, like that. So intuitively, I thought that there must be a powerful, notice how I asked the question, there must be a powerful antioxidant that protects it from degradation. I was expecting it to be a polyphenol. So surprisingly, not a polyphenol. More surprisingly, it's not a tocopherol, and most surprisingly, it only contained tocotrienol. I was already an expert in
Wow.
tocotrienol this stage, so when I found this out, then I have already found this from rice, which have 50% tocopherol and 50% tocotrienol. And then I also found this from palm, which have 25% tocopherol and 75% tocotrienol. In early days, when I did clinical studies on this, we found that the tocopherol interferes with the function of tocotrienol. This is a different kind of concept. It is antagonistic to the function of tocotrienol. So I kind of like leave the tocotrienol research for a while. And then I found this from annatto. The annatto is completely free of tocopherol. So now I got a chance to go back to doing clinical study because I don't find it contained tocopherol that put bricks on the function of tocotrienol. So the last 25 years, I've committed to do research on them after I found them. So now tocopherol, tocotrienol. And of the tocotrienol, the most active one is delta tocotrienol, like Delta Airline, and gamma tocotrienol, like that. And this annatto, you wouldn't believe it. It literally contains 90% delta tocotrienol and 10% gamma. So in other words, it is almost as good as a drug itself, except it is not a drug, and I did not manipulate it. The lovely plant make it itself. By the way, I bring this back up again. This is carotene. You know why the plant make tocotrienol? It make tocotrienol to protect the color from degradation. I have committed the last 20-something years of my life to do chronic condition. So the chronic conditions we have studied, Ben, dyslipidemia, cholesterol and triglyceride, metabolic syndrome, prediabetes, including insulin resistant, diabetic, and more recently, we finished studies on fatty liver disease. And the last of these chronic conditions, my colleague in Texas are doing, and on men and women with obesity. So these are clearly chronic conditions. If you think of a particle, they are lipoprotein. And the lipoprotein don't exactly follow everything like the cell membrane, but close enough. They got more other stuff in it. Inside the core will be triglyceride. Now, they have tested ex vivo outside the body as well as in the person. They consistently find that the LDL particle and the HDL particle, the bad and the good cholesterol respectively, they are protected from oxidation. Oxidized LDL particle is considered atherogenic. That means that they become very sticky, they cling onto your artery, and then they make a plaque. But if they are not oxidized, they're potentially bad, but they are not bad in itself. And tocotrienol is known among all the vitamin E to protect the LDL particle from oxidation. I'm saying it in the simplest way I could possibly to you. And how much to take? About 100 to 200 milligram per day, 100 for a smaller size person, 200 for larger. And for mild chronic conditions that we did it on people with pre-diabetes, about 300 to 400. And for people who are diabetic and people with fatty liver in a clinical study, typically 400 to 600 milligrams. Make sure you take it with a meal, not on an empty stomach.